Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with ATC department, and in this video lecture series we are discussing the subject called Advanced Data Structures or Data Structures 2 as you know it. Today we are going to start a new topic called binary search. We have moved on from a unit to a next unit, basically from unit 2nd to 3rd now. So binary search would be the first topic I'm going to tackle. It's a quite simple topic, but we're going to finish this. As the name suggests, it's going to search a particular element in the array of elements. Okay, that could be an integer variable, integer element, or maybe some other kind of array which we have defined. But the crux of the binary search is it's going to find out the element and it's going to return the index of the element of which you want to find out, or it's going to return null if that particular element is not found out inside the array or not. But the prerequisite or the essential condition for implementing the binary search is that that particular array must be sorted in the first place. So for any unsorted array, binary search won't be able to find out the element that you are looking for. Okay, so first and foremost condition, I'm saying that again, the first and foremost condition of implementing the binary search is that the array inside which you want to find out a particular element must be sorted. Okay, so let's read out the notes first. These notes are already been with you for quite some time now. Now, binary search is a searching algorithm for finding an element's position in a sorted array. Okay, in this approach, the element is always searched in middle portion of the array. Binary search can be implemented only on sorted list of items. I have highlighted this particular line because it's the most common mistakes students do while try to implement the binary search, that they start with an unsorted array and at the end they will be left with an algorithm which is incapable of finding out the element, but they will keep on scratching their heads as to find out what's going wrong. They will keep on looking to the algorithm, but the main problem is not the algorithm but the initial input, the initial argument that you have provided. Now that initial argument must be a sorted array, so that should be kept in mind always. So if the elements are not sorted already, we need to first sort them by using any sorting algorithm. You must be familiar with some of the quite basic of the algorithms until now, and if you are not, we're going to see them in the coming few lectures, and then you can try to implement those sorting algorithm on an unsorted array first, and then you can try to search for a particular element in the sorted array. Okay, now we have two methods of binary search algorithms. First is an iterative method and next one is going to be a recursive method, but both of them most of the time will follow the rule of divide and conquer. That is, we're going to divide the array into smaller parts and then we're going to focus on those smaller parts, the valid smaller parts. In this way we're going to reduce the computing time and the memory that is being required. Okay, so I will not go inside the notes, so you can read it by yourself. I'm going to directly come to the concept and take you to the algorithm part. Now this is an iteration method or the iterative method. I'm going to stick with iterative method because inside if you have understood the iterative method, you are going to understand the recursive method in a minute or so. So we'll also come to the recursive method, but first I'm going to explain what the iterative method do. So for that I have to go back to the paint to make you understand using a pen. Now, the very first step of our binary search algorithm is to find the middle element of the array. Now, how to find the middle element of the array? You can write the index values here. Let's say this one is 0 index, this is the first, and the second, and the third, and then the fourth, fifth, and sixth. Please pardon my writing, I'm using mouse to write. Now, as you can see, I have written the index values of this particular array here. So at the first index of the array, you can see I have stored the value 3, and then at the first index I have stored the value 4. And as you can see, this particular array is already sorted. So we are going from, when we go from index first or index 0 to index last or the sixth index, we are actually going to see the content of the indexes in an increasing order. So 3, 4, 5, 6, 7, 8, 9. Now suppose we want to find the element or the number 7. So I want to find the value 7. So 7 is my target. Okay. So after first sorting it, the next step would be to find the middle of this particular array. Now, how to find out middle? Before finding out the middle, we have to initialize 2 pointers. The first pointer will be the low pointer, and next pointer will be high pointer. The initial value of these 2 pointers will be, for low pointer, it will be loaded, or not pointers, you can also initialize 2 variables, not necessarily pointer. If you're using some higher level language, let's say Python or Java, you can use a simple integer variables. Okay, so I will call this as variable, not a pointer. So this low variable actually contains the first index, that is 0 value, and this high contains the value of last index, that is 6. So last index will be stored inside high, and first index, which will always be 0, will be stored inside the low. Now I have to calculate the middle value of it. Now how I'm going to calculate it? I just have to calculate low plus high divided by 2. Let's get back to the. So there we have calculated the middle value. All you have to do is just add the lower index and the higher index and divide it by 2. It's the just basic mathematics. You can figure it out on yourself that you are going to end up with a middle value. Now this particular middle value may be an float value. Okay, it may be a float value, but in that case, the division you have to do is and must be an integer driven division, or you can use the function called float function. The float functions are very common functions inside any language. All it will do is, if there is a float value, let's say if the middle value comes out to be 3.5, okay, then it's going to shun this point after point values, and your actual middle point will be 3 only. So what floor is going to do? Floor is going to shun all the decimal values, and you are going to end with the lower integer value. I think you all are familiar with what these are. I'm going to remove this. So let's try to calculate this middle value in this case. So the low contains value 0 and high contains value 6. So plus 6, and I'm going to divide it by 2. So I'm going to get, now 3 is the middle value right now. So where is 3? This is where it is. Or I'm going to use a different color for this, so it might be clear. Let's say, so this is our, so this is our middle value for first iteration. So this is your middle value for now, and there we have calculated it. Now the next thing we are going to do is, let's go back to the algorithm. If the value that you want to find out Now x is the actually the element that you want to find out if it is inside the array or not. If it is actually at the middle value, then all you have to do is just return the index mid. So what I'm trying to say here is, if let's say I have to find out, initially we have figured that I have to find out 7, and if the content of the middle index, let me again remind you, I have calculated the middle index as third. So if the content of this middle index, that is third index, that is actually 6, is equal to 7, then all I have to do is return this value third. I have already told you at the beginning that this particular function, which implements the algorithm for binary search, doesn't return you the value, but actually returns you the index at which the value is stored which you want to find out. So I want to find out 7. If I somehow gets to the point or the index at which 7 is stored, I am going to return the index of this. So in the end, if everything goes out correctly, my function is going to return me with value 4. Okay, that is the index. So it's the 4 is it will be signifying that at the fourth index of the array, I have the value 7, which I actually try to find out, try to search. Okay, so let's get back to the point where we are. So first, I'm going to see if the value at the middle index is equal to the value that I'm actually looking for. Now, at this particular index, that is the middle index, we have the value 6, and 6 is actually not equal to 7. So that is not the case. I'm going to be inside the if, that particular if block. Now we'll have an else if block, and we are going to see if the value that I am looking for is actually greater than the value that is at the middle index. So I'm saying is, I have to search for 7. Now I will look, now that I know that the middle index doesn't contain the value I'm looking for, I'm going to see if the value I'm searching for is greater than 6 or not, is greater than the value inside this middle index or not. Okay, so as I know, I'm looking for 7, and 7 is greater than this particular element 6, which is inside the middle index. Now what I have to do is, I have to update my low variable. Let me remind you, initially the low variable contains the value equal to 0. So this low here will not be here now. I have to update that, and that updation will be actually mid plus 1. So what I have done here is, let me erase some things. Okay, no, I will not. First I will remove this low here from here. Okay, now low is gone. Because I know that 7 is greater than this particular value, I have to update the low. Okay, now low is actually mid plus 1. Now mid variable actually contains the index of the middle value. That middle index is actually 3. Now my low value should be equal to middle plus 1. Now middle is 3 plus 1 will be equal to 4. So my low is now, my low is here. So this is my new low. Okay, this is my new low. As you can see, the low variable contains the index. The index is contained is actually 4, and 4 is actually middle index plus 1. And this is what we have done here. So low now contains 4, and it is actually middle, that is equal to 3 plus 1. Okay, let's move ahead. Now that we have already been inside an else if block, all the else and or the else if blocks will be skipped, and we'll go to the first point again. We'll go to this point again here. The first thing we have to look is, the most important thing we have to look is, if Well, I will try to type it out. If your high is actually less than low, if this condition has already been reached, that means you have looked through all the array and your particular element that you want to find out is not there. Okay, what I'm trying to say here is if this low comes out to be ahead of high, if let's say some high, this high will be updated to this particular value and your low comes here, then you can assume that you have already looked through the complete array and the element that you are looking is not there. So your algorithm is going to return, or your function is going to return -1 or null. Okay, so let's move ahead. Now this is not the case. Still the low is not greater than high. So I'll move here. Next point will be, again we have to calculate the mid value, but with this time with the updated low and updated high. Now I will first remove this, the older mid, as I have to calculate the new one. Okay, so now my high is still at, or so my low is at 4 and my high is still at 6. So this calculation is going to give me the value equal to 5. Now this 5 is actually now the new middle. So let's remove this middle from here. This is not my middle now. The middle value is updated. This middle value now contains the index number 5. So this is the 5th, and now this here is my new mid. This here is my new mid. Again, the step, first I have to look if the value at the middle index is equal to the value that I am searching for. Now the value at the middle index, that is 5 in this case, is actually 8, and 8 is not equal to 7. Okay, so that is not the case. So I am outside this if block now, because 7 is not equal to 8 value. Now I am in the else if block. First else if block is, I have to look if the value I am looking for is greater than the middle value. Now the value I am looking for is 7 and the value at the middle index is 8, and 7 is not greater than 8, so I will not go inside this else if block also. Okay, now I will be inside this last else, and if that is the case, the only case is that the value that you are looking for, that is 7 in this case, is actually less than the value at the middle index. So in that case, we will not update low, we will update high. Okay. Now how high will be updated? High will be equal to mid -1. So let's do that. Now first I will remove this high value. This is not the value that I am looking for right now. It has already been updated, and it must be equal to mid -1. Now mid has a value of 5, index value 5, and 5 minus 1 is actually equal to 4. Okay, so this also becomes, sorry to use the black color, this also becomes my high. This also becomes my high. So my high and low values are same now at this point. Okay, again I will go inside the loop and I will see if low is greater than high or not. If low is greater than high or not. Now low has a value 4, high has a value of 4. It is still not greater than high. So the low and high still haven't crossed each other, though they have reached a point where they are at the same junction. But it is not the case that low is somewhere here and high is somewhere here. If that is the case, that means we have already searched through the array and we are not going to look further because the element is not going to be not inside this array. Okay, now that we have defined or it has been proven that low is still not greater than high, we'll go inside. We'll first calculate the new middle value. Second step is calculate the new middle value. So let's calculate the new middle value. Let's erase the last middle value first. Now the new middle value must be low plus high divided by 2. Now low has a value of 4 plus high also have a value equal to 4 and divide by 2, and I'm going to again get 4. Okay, now this is my new middle value. Let's rectify it. Now this has become my middle value also. Now the next step is first I have to look if the value I'm searching for is at the middle or not. And at the middle we have value 7, and value actually I'm looking for is also equal to 7. So we will be going to be inside this if block, and the value in of the mid, that is the index of the mid, that is equal to 4 will be returned. And I think we have found out what we are looking for. The algorithm binary search has found out the index for the value that you are actually looking for. Okay, so this is how your binary search continues to work. All you have to see is if your value is at the middle. If it is not at the middle, you have to look if your value is less than middle. If it is less than middle, you have to update the high variable to mid minus 1. If your value is actually greater than the middle, then you don't have to touch the high variable. You have to update the low variable. Low variable will be now equal to mid plus 1. And again, you have to first look if your lower index value is greater than higher index value or not. If that is the case, then you have already searched through the whole let's say array and your value is not in there, your content is not in there. If that is not the case, you have to repeat the same procedure again until your middle value is equal to the value you are searching for. This is how your binary search will converge. Okay, I think you have got the point what I am trying to say. In the recursive method, you can see that I have done almost the same thing. If low is greater than high, then return false. It means we have already the low pointer and high pointer, low variable and high indexes have already crossed each other. So the number is not going to be inside the array. Else, all you have to do is calculate the new middle, see if your value is at the middle or not. Else, you have to return again, call this particular binary search, and this time for the low index you have to pass the argument mid plus 1. So this is basically same thing, but we have updated the low index value for mid plus 1. And in the next case, if that is not the case, if x is on the lower side of the middle, then in that case you have to update the high. You will again call the binary search method inside the binary search method, and this time instead of passing on the high index, you are going to pass the value called mid minus 1. So this is basically the same thing that I have done here, I have explained here. You can use any one of these methods or the algorithms to implement the binary search. Now the time complexity of binary search is order of log n, so it's quite fast. And I think we have concluded with the binary search. Thank you.